So in the last session we saw about trigonometric ratios and how to convert from one ratio to another, how to write one in terms of the other. So we'll continue with some more problems, some of which involves both the complementary angles as well as the identities. We'll see that as we go on. Okay, so the first question is, evaluate sine square 63 plus sine square 27 by cos square 17 plus cos square 73. So this has squares as well as, you can see 63 plus 27, that is 90. So here also you see 17 plus 73, that is 90. So the approach that we can take is sine squared 63. What is sine 63? How can I write? Can I write it in terms of cos? Yes, that is cos 90 minus 63. So let's write it as that, cos 90 minus 63, and since it is a square, so it will be cos square plus sine square 27 by cos square 27 is can be written as sine square 90 minus not 27, it is 17 plus cos square 73. So we get cos square 27 plus sine square 27 by sine square 73 plus cos square 73. So when you see this, you immediately notice that it resembles one of the identities that we have learned. Sine squared theta plus cos squared theta equals 1. So here also 27, you have 27 here too. So the numerator becomes 1. What about the denominator? Sine squared 73 plus cos squared 73. Same form. Sine squared theta plus cos squared theta 1. So it is 1 by 1, which is equal to 1. Okay. So let us go on to the next one. So the next question is sine 25 cos 65 plus, this is all in degrees, plus cos 25 degree sine 65 degree. So now we have this, and here too what do we see? We see 25, 65, when you add that it becomes 90. Here too you have 25, 65, it becomes 90. So let us see what we can do. Sine 25 and cos, if we convert to sine, what do we get? Sine 25, and this becomes sine 90 minus 65, and this becomes, this is completely in sine. Suppose we want to do all of that in cos. So cos 25, and this becomes cos 90 minus 65. So sine 25, and this one sine 90 minus 65 is sine 25. So sine 25 into sine 25, I can write as sine square 25 plus there cos 25, cos 90 minus 65 is also 25. So cos 25 into cos 25, that becomes cos square 25. So this is also of the form sine squared theta plus cos squared theta, this is equal to 1. Now we go on to the next question. So the question is 9 into secant squared A, 9 secant squared A minus 9 tan squared A. So immediately we see that 9 is common over here. Take out the 9, you get secant squared A minus tan squared A. Secant squared A minus tan squared A is 1. So I get 9 into 1, which is equal to 9. So when you're doing these problems, if you're using a particular identity, I suggest by the side, please write secant squared A minus tan squared A equals 1. Using this identity, you are doing this. Okay, so that it's easy for the examiner to understand your thought process. So now the next question. One plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Now in this we have tan, secant, cot, cosec. Let us make everything in terms of sine and cos. So what do we get here? 1 plus sine theta by cos theta plus 1 by cos theta into 1 plus cos theta by sine theta minus 1 by sine theta. So in this group that we see that let's take it together. Let's take the denominator, the LCM as cos theta becomes cos theta. So here 1 into cos theta is cos theta plus sine theta plus 1. So let me group this. So sine theta, cos theta plus sine theta plus 1 into this one has, what is the denominator that we can take as LCM? Sine theta. So 1 into sine theta, here you get sine theta plus cos theta. Let me group this minus 1. So when you see here in the numerators, you will see sine theta plus cos theta plus 1. Here sine theta plus cos theta minus 1. So it is of the form a plus b into a minus b, and a plus b into a minus b is nothing but a squared minus b squared. So I can write this as cos theta plus sine theta whole squared minus 1 by cos theta into sine theta. So let me write it here, sine theta cos theta. Cos theta sine theta or sine theta cos theta, the order in which you write the multiplication does not matter. So here what do we have here? A plus b whole squared. So let me expand that. So when I expand that, what do I get? I get cos squared theta plus sine squared theta plus 2ab. A plus b whole squared is a squared plus b squared plus 2ab. There are many who forget that 2ab. So 2 into cos theta sine theta minus 1 by sine theta cos theta. So now cos squared theta plus sine squared theta, by identity we know that it is equal to 1. So let me write it as 1, there is a minus 1 there, plus 2 sine theta cos theta by sine theta cos theta. So 1 and the minus 1 cancels, and you have 2 sine theta cos theta by sin theta cos theta. So I can cancel this up, cos theta, and this is equal to 2. I have seen many students doing a mistake like this. Suppose I get a plus b by b. I can see them cancelling this and this straight away and writing the answer as a, which is not correct. This is wrong because the b is both for a and b. So this becomes a by b plus b by b, and only then should you do the cancellation. So this is a mistake, a very common mistake I see many students do. So please keep that in mind and don't commit that mistake. Now let's go on to the next question. The next question is secant A plus tan A into 1 minus sin A. The easiest method is making all of that into sin and cos. So secant A is 1 by cos A plus tan A is sin A by cos A into 1 minus sin A. So the denominator, let's take the LCM cos A in this group, and it becomes 1 plus sin A into 1 minus sin A. So the numerators you can multiply a plus b into a minus b, so it becomes 1 minus sin squared A by cos A, and 1 minus sin squared A is cos square A. So I can write it as cos square A by cos A, which is equal to cos A. So one of the cos A's cancel up and down, so the answer is cos A. So let's move on to the next question. One plus tan squared A by 1 plus cot squared A. So one of the easy ways to do it is, there are many ways. So in many of these problems, the approaches taken by different students are different. So there's nothing that this is the only approach, there can't be another approach. But finally we have to prove whatever is given. So in this case 1 plus tan squared A, and I can write this as cot squared, I can write it as 1 by tan squared A. So the denominator, if I take the LCM there in the denominator, it becomes tan squared A, and tan squared A into 1, tan squared A plus 1. So I have 1 plus tan squared A here and here. The tan squared A goes up, and I get tan squared A into this 1 plus tan squared A by the denominator. There also I have tan squared A plus 1. I can write it as 1 plus tan squared A. So these two get cut, and what is left is tan squared A. So when you are watching this video, please try to do each of these problems yourself. Stop it, try to do it, and if you are not getting it, watch the solution. That is what I would suggest. So the next one, prove the following identities. So cosecant theta minus cot theta whole squared, prove that this is equal to 1 minus cos theta by 1 plus cos theta. So now in this, let me make it in the form of, let's take the left hand side. Cosec theta is 1 by sin theta. Cot theta is cos theta by sin theta whole square. So the LCM is the denominator sin theta, and I have 1 minus cos theta whole square. So I can rewrite this as 1 minus cos theta whole square by sin squared theta. And what is sin squared theta? It is 1 minus cos squared theta. We know that identity. Sin squared theta is equal to 1 minus cos squared theta. So let me write it as 1 minus cos theta. The numerator is 1 minus cos theta into 1 minus cos theta. That is the 1 minus cos theta whole square by 1 minus cos square theta. This 1 minus cos square theta, I can, instead of writing it as 1 minus cos square theta, I can write it as 1 minus cos theta into 1 plus cos theta. I suggest you show both the steps. Here, for want of space, I did the step here itself. I just erased it and I did it, but please don't do it yourself. So these both get cancelled, and what is left? 1 minus cos theta by 1 plus cos theta. So it is proved. Now let's go on to the next one. Cos A by 1 plus sin A plus 1 plus sin A by cos A equals 2 secant A. This is what we have to prove. Let's take the left hand side. Let's take LCM. Let's multiply this and this. 1 plus sin A into cos A, cross multiply cos squared A plus 1 plus sin A whole square. I hope you are familiar with the basic LCM method of adding fractions. So that's the same technique that we are using here. So it is cos squared A plus, this is A plus B whole squared. So what do we get? A squared, 1 square is 1, plus B square, that is sin square A, plus 2AB, that is 2 into sin A into 1. So that is 2 sin A by 1 plus sin A into cos A. So cos square A plus sin square A, we know by identity, it is 1. So I can put 1 plus 1 plus 2 sin A by 1 plus sin A into cos A. 1 plus 1 is 2, so I can write it as 2 plus 2 sin A by 1 plus sin A into cos A. Now it is 2 plus 2 sin A, so 2 is common over there. So what I can do is, let me take the 2 out. So it is 2 into 1 plus sin A by 1 plus sin A into cos A. So the 1 plus sin A gets cancelled and I get 2 by cos A. And what is 1 by cos A? 1 by cos A is secant A. So I can write it as 2 secant A, which is equal to the right hand side. Hence we have proved this. So slowly as we keep doing this, you will start getting the hang of how to look at identities, what would be the easiest way to do it, and sometimes you may come up with your own methods also. So keep doing. The more you practice, the better you become. So now the next question. So tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta equals 1 plus secant theta tan theta. Now in this problem, let's take the left hand side and let us write the sine, the tan and the cot in terms of sine and cos. So what happens over here? Sine theta by cos theta by 1 minus cos theta by sine theta plus cos theta by sine theta by 1 minus tan is sine theta by cos theta. Now in both the cases, let's look at the denominator and let's take the LCM in the denominator. So this becomes sine theta by cos theta by, the LCM is sine theta over here, sine theta into 1, sine theta minus cos theta plus cos theta by sine theta by, let's take the LCM, cos theta into 1, cos theta minus sine theta. Okay, now let's make the expression much simpler. Let me keep that right hand side over there because this is where we want to reach, because otherwise we may not know whether we have reached. We will keep on going. So it's very important to have an eye on what is there on the right hand side, because the left hand side could be the same and they could make it a different version on the right hand side. So here the denominator, this goes up, this goes here, similarly this goes up and this goes here. So now I can write it as sine theta into sine theta, that is sine squared theta by cos theta into sine theta minus cos theta plus, the cos goes up, so it becomes cos squared theta by sine theta into cos theta minus sine theta. Now we see here we have a sine theta minus cos theta, here I have a cos theta minus sine theta. If I want to make it sine theta minus cos theta, I have to take a minus out and write it as sine theta minus cos theta. It is just like this. Suppose a minus b is there, I want to write it as b minus a. So what do? I take a minus out and write it as b minus a. Similarly, I am going to do this, and at the same time I am going to do one more thing. Here there is a cos, there is a sine. I want the denominators to become the same, so I am going to multiply the sine over here, sine theta. When I multiply in the denominator the sine theta, what should I do? I should multiply 1 in the numerator too. And here I am going to multiply a cos theta. So cos theta, and here in the numerator I multiply a cos theta. So what does this become now? So you have to be very careful when you do this problem, because there is a sign change I am doing, and also I am making both the denominators same, for which I am multiplying sine here and cos there. So this becomes sine cube theta by sine theta cos theta into sine theta minus cos theta. And now there I am going to change the sign, so I am going to put a minus out, and this becomes cos cube theta by sine theta cos theta into sine theta minus cos theta. So now what have I done? I have made the denominator the same in both of these terms. So I can write it as one denominator. So sin theta cos theta into sin theta minus cos theta. And what comes up? Sin cube theta minus cos cube theta. This is of the form a cube minus b cube. What is a cube minus b cube? A cube minus b cube is a minus b into a squared plus ab plus b squared. Let me also tell you what is a cube plus b cube. That would be a plus b into a squared minus ab plus b squared. Keep this in mind, this is very important. This comes in many problems. So now a cube minus b cube, so let me write it as sin theta minus cos theta into a squared, that is sin squared theta plus sin theta cos theta plus cos squared theta by sin theta cos theta into sin theta minus cos theta. Now let's cut the sin theta. Sin theta minus cos theta, sin theta minus cos theta. Sin squared theta plus cos squared theta is 1. So I can write it as 1 plus sin theta cos theta by sin theta cos theta. So what happens there? So let me further break it up. It becomes 1 by sin theta cos theta plus sin theta cos theta by sin theta cos theta. So 1 by sin theta cos theta can be written as 1 by sin theta is cosecant theta and 1 by cos is secant theta. So secant theta cosecant theta plus this both cancels, you get plus 1, or I can write it as 1 plus secant theta cosecant theta. So we have the right hand side over here. I hope you understood how we did this problem. Please do all the problems that we did in this session by yourself, and in the next session I will continue and we will do more problems.